Good morning, FHS. This is Superman speaking. Um, Ready to dive into Unit 2, Notes 2, grasp some systems of inequalities. Now, what you need to understand here is yesterday we graphed a bunch of lines, equal signs. Now we're going to do it with inequalities on the same graph. And they're going to mean basically the same thing, but we're going to take a look at it. So, what I'm talking about, grasping systems of inequalities. A system of linear inequalities is a set of two or more inequalities on the same graph. So right here in white is the solution. Okay, where these two colors meet, all this in red, is your solution set. Okay, so that means you can pick points like -5's right here. So if I go up 3, -5, 3 is a good solution to have. Okay, so that's a possible solution. Really, any values that fall in the solution set are going to be solutions for your inequalities. And I'll show you what that kind of means later in our word problem. The solution is the region where both of the inequalities are shaded. All right, so you see that. Graphing systems. All right, so just remember it's just your y-intercept and your slope again. So I'll do this top one in blue. All right, that's dotted, if you remember that, and below, because it's less than. Less than's below, greater than's above. Less than's below budget, greater than's above budget. That's what I think of. Dotted is just less than. So then right here in red, all right, we'll try black. You have a solid line, solid, but then that's still below as well. All right, so I'm just going to do the second one first, +3. All right, and then I'm going up to something like this. Okay, I got a solid line there, good to go. We'll grab this blue marker again, +1, and then it's a dotted line. All right. If you need to still put the little circles on the graph, go for it. Now, it was below the blue line. Then I forgot to shade you here. It's below the black line. Notice I'm going kind of perpendicular to the line. Alright, so you guys should be able to see which line they correspond with. Alright, so my solution set is all this down here in red. That's where both colors cross. That's your solution set. That's what we're looking for in all these. So you got to know above, below, which side of the inequality you're graphing on. Then you also need to know if it's a dotted or solid line. So I'm still looking for all those things when you do your paper. So let's try this again. I got above and dotted. So let's do that. +1 above. Oops, there's a meeting. Oh, too sad, too bad. Alright, above. So I'm going perpendicular. Sometimes I like to scribble. Alright, let's try this once. How about -3? Look at that, I changed it to purple. Multi-talented today. Alright, so this is dotted and above. Look at that, I can say it. I'll write it down real quick. Above. No, below. Excuse me, this is a less than sign. So, I'm running up here. And so, for a solution set, do they cross paths anywhere? No. Alright, in this gap here, this is no solution. Okay. This is where an example of these two right here, they both have a slope of 1. They're the same slope. Those lines are parallel. We talked about that a little bit before. If they're parallel, they're no solution. So here you can see a graph of a no solution. It's not going to happen a lot, but you got to be aware of it. All right, here's two examples where they didn't give us slope-intercept form. So you still got to be able to manipulate these to what we want. So I would say this is negative y greater than or equal to negative 3x plus 6. All right, then I got to multiply by negative 1. When I do that, I get y. Flip the sign is 3x minus 6. Okay, that's below and solid. So below negative 6. How do I want to do this? 6, 3. I know it's a solid line, so I don't mind making circles then. Something like this. Alright, so I'll shade this below. Remember, even if it's a steep hill, it's still underneath it. Here, I just got to move my 2x over, so this shouldn't be too bad. Here you have the bell going off. Alright, 2x is 4. Am I doing this right? Negative 2x. Fix my little line here. So let's go back. 4, negative 2x. And it's a solid line. And it is below as well. So I'm going to go below as well. That would mean it's down here. And you can see down in this little area down here is where I have 2 solution set. I'm not going to get hung over on that or hung up on that. Here you have below, and to be honest with you, there's no slope here, and you should know that that's just a vertical line. What I mean by it is this is 3, right? It's the solid line. Does below help me? No. So if that's something you get hung up on, that's fine. But you should be able to sit here and tell me when x is equal to 0, it's less than or equal. That's a true statement. Okay. In other words, what I'm trying to tell you is everything on this side of x is less than 3 should be shaded. So that's a lot of area that's covered. It's fine. We'll just leave that one. Let's try this. Negative x plus 2. So on 2, that is a dotted line, and it's just a slope of negative 1. So I got a dotted line. Doesn't really matter. Now that is above that, meaning that it goes like this. And you guys should be able to see where the solution set is. If you got, I probably should mention this here. So if you're writing pen or you only have one color, I would shade lightly where I have this red here. So out here where I have red, I would shade lightly. Here where I have green, I'd shade lightly. And then here, I just color it in or shade it enough that I know you know this is a solution set. Things like that. Alright. So then 2 more. And here you go. Here's another example. Y is greater than 3. That's actually going to be a slope. There isn't a slope at all. So that's a horizontal line. Should have wrote vertical on the other one. Where's y? This is where y equals 3. You guys might have to check for my mistakes. I'm going to screw up these dotted lines and everything. It says above. So above dotted. Now, negative y is greater than negative x plus 4. So negative x plus 4. Here's 4. Negative x. Something like this. Alright, negative x plus 4. So I need to be above that as well. So that would be this area. Alright, see how when I do, even if I have the same color, then I might just shade this in a little bit. Okay, that's my solution set up here. Set red down. Awesome, these are in slope-intercept form for me. So this is below and dotted, and this is above and a solid line. So let's just do positive 2. This is my dotted one, right? My lines aren't straight today. Use a straight edge. If you want a ruler for this stuff, I do have some available for you. You guys just gotta ask. So I'll make that dotted, and I need to know it's below out here. I'm gonna try and pick up the pace here. Negative 3, negative x. That's a solid line. So I'm going like this. And that's above. So if I didn't make a mistake, I was looking for out here. Let's keep moving. So this is what we gotta get to. Flip it over the back side. The most Jack can spend on bagels and muffins. So bagels and muffins, there's two variables is what I'm thinking about. So a package of, you can spend $28. A package of 6 bagels costs $2.50. A package of muffin costs $3.50 and contains 8 muffins. He needs to buy at least 12 bagels and 24 muffins. So there's a handful of inequalities here. What I know is that I want x to equal number of packages of bagels. Alright, and then y will equal number of packages of muffins. Alright, so the x and y are actually standing for the number of packages. There's a little bit of information here. So how many packages do I need to buy? Okay, it says he needs to buy at least 12 bagels. So for x, if x equals number of packages of bagel, a pack of bagels is 6. So I need to know right now that I need to buy greater than or equal to 2. Meaning if I buy 2 packages, I have at least 12. That works out. So then the same thing for y. Y is greater than or equal to, I need 24 muffins. Okay, well they come in packages of 8. So that means I know that y has to be greater than 3. Now for the last thing, kind of the ones you guys were quizzed on in Unit 1, you need to know 2.5x, so $2.50 is each cost of each package, and then muffins is $3.50, so plus 350y has to be less than or equal to 28. Alright, make sure you kind of pause. This would be a good one to understand. I have these ones are done. This one I solved for y because I wanted it in slope-intercept form so I can graph. Alright, if you do that, you get y is less than or equal to negative 5 over 7x plus 8. So that's what I get. You should be able to do that on your own. So make sure you can do that. Okay, now I can go into graphing it. So that's the last one I graphed. Graph the last one first. So I count out 1, 2, 3, 4, 5, 6, 7, 8. So 8's here. And then I'm going down 5 over 7. 5, 6, 7. Okay. I'm going to draw my solid line in here. I know they're all greater than or solid lines are equals to. All right. Here I know that that is less than. I'm kind of giving you guys a hint right now. So x is greater than 2. So I can count 1, 2 over here. That would be x is greater than 2. Remember, x is bagels. Bagels. Y is muffins. Okay? And muffins here are greater than 3. So y is greater than 3. Okay, I'm just going to stop there. I don't need to make big long lines. Alright. So, this one was greater than, so greater than 2. And this one's greater than 2. So I'll kind of show that here, guys. This is greater than 2. This is greater than 3 out here. So I'm going to shade that in. So this is my solution set in here. That means I spent too much money. If I go above, to the left of the red, that means I didn't buy enough bagels. If I go below the blue line, that means I didn't buy enough muffins because I needed to have at least 12 bagels and 24 muffins. So I'm cornering it in. Now, give an example of 3 different purchases I can make. Jack can make. Jack's the main character here. So what I would do is I go find a point up here. So I'm 1, 2, 3, 1, 2, 3, 4. So that's a point inside our solution set. Because I got my x-axis labeled there, I know that point is 3 bagels. And it's up 4, so 4 muffins. Perfect. Alright, let's go over to the right one. That's just going to be 4 bagels and 4 muffins. I could actually just do, I could go right one more. This would be 1. Let's go up 1. Okay, so up 1 would be 4, going back to 3 bagels. And then 3 bagels. Oh, it looks like 5 muffins. Okay. That's what I'm looking for you guys to be able to do. Alright. Graph these inequalities. Understand what the word problem is saying. And then understand what the solution set is. 3 bagels, 4 muffins. Alright, that makes sense. You could do some math and figure out how much that costs. I guarantee you it's less than 28. But that's a good, solid word problem. Alright, sometimes we might just ask you to read an inequality graph for us, or something on the ACT might ask you what that means. Okay, this is a great problem. This is kind of why I love math, or Superman loves math, I mean. So let's make this one. This one's a little bit easier. This one's just 2, because we go back to, we got to figure out our money. So he makes $10 an hour cutting grass. So I like to set x equal to hours cutting grass, y equal to hours raking leaves. Alright, so there's 2 things here. First thing is he cannot work more than 15 hours per week. Graph 2 inequalities that Rondell can use to determine how many hours he needs to work at each job if he wants to earn at least $120 per week. The word graph 2 inequalities tells you I need 2 inequalities here. The one is you look at hours. So he can't work more than 15 hours per week. So number of hours of cutting grass plus the number of hours raking leaves has to be less than or equal to 15. Perfect. That's a good one. Now I got to add in the money piece of it. Okay. The 10x plus the 12y. Now what am I trying to do? He wants to earn at least $120 per week. At least is greater than 120. So this is good. Alright, the first one up here is just subtracting x to each both sides. So y is less than or equal to negative x plus 15. Let's get this on there. I don't want to waste time. 5, 10, 15. Okay, that is a solid line and it's below. So I'm just going to go. Oop, I dove at the end there. I don't know why, but it's alright. Now, this last one, I gotta do a little work here. Hold on. Minus 10x. I like to leave that as plus 120. So I know that 12y is greater than or equal to negative 10x plus 120. 12, 12, 12. Y is greater than or equal to negative. 2 goes into both of them. They're both even numbers. 5, 6. Sweet. Plus 10. Okay, negative 5, 6 plus 10. So I'm going to go, good thing I counted to 10 there. Down 5 over 6. Down 5 over 6. Right here. Okay. Solid line again. Good thing I can draw straight. Alright. So, this one said greater than. So this one's in here. And then the red line was less than. Oh, so it's going to be all this stuff in the middle. So I want you to listen to what I say here. Alright. Obviously, he wants to make 120 bucks. So your solution set could be any points in here. So let's just pick this one. That is 2, 4, 6, 8. I can't count. 2, 4, 6, 8, 10. So I got 10. Well, 10 what? This is X was grass. So this was leaves. So 10 hours of cutting grass and 3 hours of raking leaves. Could be a possible solution. Alright, all those things could work. You know, it depends on the flexibility of a schedule, things like that. Long-winded. Two more. Let's stay with me. Alright, this one's in black. This is above and solid. So, x is greater than or equal to 0. Here it is. I know where x equals 0 at. Is that? I know it's this way. I'm just going to stay out of the middle because I'm guessing it's going to go in the middle. Alright. I got to do a little math here. For this one, in red, I got to subtract x from both sides. It's less than or equal to negative x plus 2. Then divide by negative 2, divide by negative 2, divide by negative 2. I get y. Flip the sign. 1/2 x minus 1. So I find negative 1, up 1 over 2, up 1 over 2. So that's solid and above. Notice I'm going to just stop right here because I know this one's above. So just little marks to let you know where it's going. Alright, so then this last one in blue, I'm going to subtract 3x from both sides right away. So I'm going to have 4y is less than or equal to negative 3x. And divide by. I like when I divide how I write it under all of them so I know what I'm doing. Because I made that mistake when I did it earlier on my notes. So positive 3 down 3 over 4. I can be done. Because I should be able to see that it is below this. So it's in here. And if I switch colors, this is the area I'm looking at. Right. I'm reading it off my notes sheet, so I can tell you that's right. But you should see above the red, below the blue, and right of the black. So I got a nice little three-sided triangle there. And I filled it in purple. Last but not least, I got this scared guy here, nervous, shaking, because there's 4 of them. Let's just look. X is less than 2. So this one is my favorite. I can jump to it right away. Alright, off the graph. Alright, it's over here somewhere. It's to the left. So that's black. This one, it has a slope of up 1 over 4. It doesn't have a y-intercept, so I can see this one. Up 1 over 4 would be over there. That's good enough, because now I know that's got to be on this side. I know it's got to be on this side. That is greater than, so that's above it. So that's somewhere here. I can graph out here or something. I don't know. Alright, green. That's hard to see over here. Positive 9. So 9's up here. Don't start to panic. It's going to be okay, I think. 2x. So up 2 over 1. That puts me off the board. I know if I go down 2 back over here, that's just 7. Okay. Bam, 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 bam. So something like this. Oh, see, I told you. Look at what I did. That's why I didn't plot plus 9. I'm fearless. Alright, so that works. Drag this back over a little bit. Somewhere like that. Close enough. Alright. Last one. What color didn't I use that? Blue. I gotta go back a step. Green is above it. Oh, so that's out here. So I'm getting way up there. Blue. I gotta cheat a little bit. Minus x, 3y. That's less than negative x plus 9. Divide by 3, divide by 3, divide by 3. So then this one's going to be, so that's my, just saying my next step's over here, is less than negative 1/3 x plus 3. 3 is here, and then it was negative 1/3, so down 1 over 3, down 1 over 3. That'd be up here. My blue line is not very straight over here. Is that above or below? That is below. Okay. I got a question for you. Did we need the black line at all? We actually are not using the black line here. I got to be above this, to the left of this, and underneath this. So this is my solution set. Alright, is the black line maybe helped me for a little bit? I knew it had to be to the left, but actually that green line canceled the black one out, per se. You could say that, or whatever. But the solution set is pretty far to the left there. Alright, I know I got a little long-winded here. This is a tough one. You guys usually struggle with this in the past. So make sure you're asking questions, ask your neighbor, all those things. Alright, great job. Superman out.